Okay, in the previous podcast, I said maybe I'll talk about agroforestry in rubber plantations in Thailand, but I read it and then decided there wasn't enough interesting material to have a podcast on it. So I'm jumping forward to a nice report from Boston Consulting Group on accelerating climate action with AI. It's a nice report. People complain about whether BCG, McKinsey, uh, all these big names have the expertise to actually do this, but I read them, I find them useful, then I include them in my podcasts briefly as always. So this report aims to provide policymakers, corporate decision makers and climate leaders with a clear and concise understanding of the role that artificial intelligence can play in climate action, as opposed to improving climate models or making predictions using AI and so on. Let's run through the executive summary and then we'll look at some additional points. As I said, I've picked up some bug from the vacation. Accelerating climate action is imperative as we are on a path to fall short of the Paris Agreement's goal to keep warming under 1.5 degrees Celsius, which we have discussed elsewhere. The UN IPCC estimates that based on action to date, the world will likely see warming of 2.8 degrees C with catastrophic consequences. Yes, there are many bad things that will happen. Already happened this past year, and now 23-24, which was very warm, came close to 1.5. So the caveat that I always say is that we are still not very good at saying what the local impacts will be, hyper-local impacts. By scaling currently proven applications and technology, artificial intelligence or AI has the potential to unlock insights that could help mitigate 5 to 10% of the global greenhouse gas emissions by 2030. That's a really remarkable potential if we can harness it, because we are at the end of 2024 and 2030 is right here at the door, and significantly bolster climate-related adaptation and resilience initiatives as well as a potential. So 87% of executives view AI as having the potential to address climate issues. AI's positive impact will be multiplied should it contribute to scientific breakthroughs that open new pathways for climate action. AI action can contribute to climate action by reducing emissions, guiding adaptations to unavoidable climate change impacts, and providing foundational capabilities that enable climate action. Mitigation, of course, helping with reduction and removal of emissions, adaptation and resilience, so aiding countries, regions, cities, citizens and businesses in forecasting climate-related hazards, developing plans to address them and to respond in real time to crises. So this is early warnings with the last mile gaps of implementation and on the street responses to early warnings all covered. And AI can help. I myself am involved in some work on using AI for helping farmers, flood forecasts, getting into health forecasts and so on. Foundational capabilities enabling climate-related modeling, research into climate economics and new approaches to climate education, and supporting breakthroughs in fundamental research. This is all climate education according to me, but I'm not using much AI other than to report on AI that I find interesting. So while AI is only just starting to be applied to climate challenges, leading edge organizations and use cases are already delivering results and demonstrating the promise of AI for climate along with 3 dimensions. The report in fact has many examples that I'm going to skip. Information, AI curated information sources are aiding nations in shaping their climate strategy and in responding to emergencies such as wildfires, but everything else as well, heat waves and so on. Predictions, AI's predictive power is helping save lives by offering advance warning of floods. This is quite a limited pointer actually. I have podcasts on how AI is being used already by Google and others, and how AI is used for understanding Earth system science and so on. Optimization and AI applications are enabling organizations to understand and reduce their scope 1, 2 and 3 carbon footprints. If you don't know, don't worry. If you know, you know what it is. Basically, scope 1 and 2 are the upstream emissions before you manufacture something. Scope 3 are downstream, where you manufacture something, hand it over to be shipped to retailers and so on. So a lot of details there. AI also poses risks that must be considered and managed thoughtfully to ensure its use has a net positive impact on climate. Life cycle analysis kind of thing will be needed. So energy related greenhouse gas emissions, we've already talked about how AI and crypto, or what do we call it, block, I'm blanking out suddenly. So they are also hungry for fuels, energy, water, and so on. Blockchain technology, that's what I was trying to say. I know it would come to me. Water use, they are very, very water hungry, and many of the big corporations like Apple, Google, Amazon, Facebook, Microsoft are going after nuclear, renewable energy, geothermal, etc. to manage their clouds and other hungry services they provide, including AI. Waste, while data centers currently account for only a small fraction of the world's e-waste challenge, there is an opportunity for tech firms to build on early circularity successes and take a more thoughtful approach to embracing more recycling and reuse. So circular economy or circularity is where from the beginning to the end you have basically reused all the material after use life cycle and so on. Can we build everything to be completely recyclable and reusable? Well, we have to try, right? Other potential risks, of course, AI applications should be sustainable and equitable by intention, and there are plenty of evidences that the AI tools we build actually inherit some of our implicit and explicit biases. So I have to really watch out what they are doing. How we define artificial intelligence, important to understand what BCG is doing. According to the Massachusetts Institute of Technology, which is in Cambridge, Massachusetts, AI is defined as the ability of computers to imitate human cognitive functions such as learning and problem solving using math and logic to simulate the process of reasoning that helps humans to learn from new information and make decisions. For the purposes of this report, we are using a broader definition of AI that comprises a set of mathematical and computer science techniques aimed at analyzing data to help understand and navigate real-world phenomenon through providing better information, so descriptive use cases are given, delivering improved predictions, predictive use cases are given, and suggesting optimization moves and recommendations to reach targets, prescriptive use cases are also reported. I'm going to jump them all because I want to keep it brief. These goals can be attained by applying wide range of techniques, including those in the table below, all of which we include in this report's definition of AI. So we will look at the table here. I won't go into the examples and climate-related example, but read one of them. Advanced analytics, so the use of advanced mathematical and statistical techniques to develop insights from structured and unstructured data. Supermarket inventory management is an example. Energy consumption optimization is a climate-related example. Machine learning, training computers to learn and make predictions from data. Historical data constitutes the inputs, while predictions based on new or unseen data are outputs. So it can find something, feed itself, and develop the bootstrap, let's say, in a crude way. Credit card fraud detection is the general example, and predicting wildfires is the specific example, but there are many, as I said, for water, agriculture, irrigation, health, energy, transportation, buildings, and so on. Deep learning, a specialized form of machine learning that uses artificial neural networks to generate hierarchical insights from diverse datasets such as images, text, or audio. These models are able to recognize patterns or features within the data, for example, by identifying objects in images, medical image evaluation, lots of good news there. Extreme weather prediction, wide applications already done. And finally, large language models, advanced AI models trained on vast amounts of text data and able to generate human-like text as output, such as for generative AI use cases. Customer service chatbots are one that ask you questions, respond, and then take you in the right direction. But you know how frustrating it is when we don't have a person to talk to. But green technology innovation is the example of climate action from LLMs. Okay, so how do we estimate AI's potential contribution? Brief, jumping ahead. Based on our research and experience, the three broad areas in which AI can accelerate climate progress are the following: mitigation, adaptation, and resilience, and foundational capabilities, as we read in the executive summary, helping with both the reduction and removal of emissions and with the underlying measurements needed to size the challenge and track progress. So it's about instrumentation, monitoring, producing bite-sized information out of that, helping models make predictions, and overall mitigation. And of course, monitoring, evaluation, and reporting is very critical. Adaptation and AI helps. Adaptation and resilience, aiding citizens, countries, regions, cities, and businesses to prepare for and respond to the inevitable impacts of a warming planet. Foundational capabilities, enabling climate action via improvements in climate modeling, climate economics, and climate education, as well as accelerating breakthrough innovations that will open new horizons for climate action. So, vast potential. Climate is an interlinked multi-parameter system. So climate scientists typically look at the Earth system wiring diagram and look at the geosphere, the biosphere, and the ecosphere. Well, geosphere, biosphere, and the physical sphere, whatever we called it. And I'm losing my mind here. And we talk about the anthroposphere, where humans influence the whole system and have feedbacks. Here, for big data and AIML, you want to think that this as a big data problem. So you still want to look at human activities and core climate characteristics, climate change processes, and also look at major impacts and the feedbacks between them. And remember, AIML doesn't need any physics. You give it data and it can extract a lot of the things, and then you can see what physics it may be pointing to. And best option is always to combine data and models, dynamical models, to make predictions, because AI may be very good at interpolating, but prediction may be in extrapolation, where you can have issues, right? So leaders believe AI can play a role in climate action, especially in helping reduce emissions. So these are the areas. 87% say AI will be helpful, as we saw. Reducing emissions, measuring emissions, predicting hazards, managing vulnerabilities, removing emissions, so reducing and removing, facilitating climate research, climate economics, and education, as we said. Okay, so this accounts for mitigation, adaptation, and resilience, and foundational capabilities. Key AI applications to accelerate climate progress comes again in mitigation and adaptation. We've already talked about this, basically measurement, monitoring, reduction, removal, hazard prediction, vulnerability management, and foundational capabilities at these various thematic directions. And all these are already happening, by the way. I'm skipping these because I've discussed these elsewhere under using AI to understand Earth system processes and so on. Critical factors determining AI's emissions footprint. So this is what we have to worry about. Using AI seems like a silver bullet to help with everything, but it comes with a huge cost in energy and water. AI-related energy growth, feeding data center operations, developers building AI models, and end-user demand for AI-enabled products. So we don't even know how much AI we are using, because everything we do now, every device you use has AI. Even Google search engine now gives AI response at the top and so on. So AI-related emissions here, then energy source, carbon intensity, data center infrastructure, model development and coding, and AI adoption and usage in these boxes. Okay. Critical choices can shape AI's emission footprints. I won't read all the details, but you can think of baseline and reduced emissions out to minus 100%, increased emissions out to 100%. So AI adoption and usage, baseline, current AI compute consumption. There is of course potential for a lot of reduction, but we don't know what the increased emissions are as of yet into the future when we compare to the baseline. Model development and coding, so evolved in 2019 and primer 2021 for models. Again, there is a 80 to 90% reduction potential. Data center infrastructure for services versus non-IT equipment, and energy source, carbon intensity, etc. So there are examples like Norway, Brazil, and US and FLAP-D countries. Singapore and South Africa are growing in their emissions there. Okay, I read what FLAP-D is, but you will have to go and look at it. Okay, should I do that now? Let me do that in real time so that I don't leave you hanging here. But search process, when you have free version of the Adobe, is always tricky. Here we are. Flap. Oops, flap. Okay. La la la. Where are you, buddy? Ah, it doesn't. It uses flap D, but doesn't define it. That's funny, isn't it? That's why maybe I don't remember it. Is there a list of acronyms? BCG, blah, blah, blah. Okay. I will leave it as homework for you. Okay, so maybe I have gone ahead and not searching properly. That's always possible because I'm not very smart at these things. Nope, it's not defined. What do you know? Okay, sorry about wasting time on that then, but let's continue. Okay, so AI for climate, summary of critical policy outcomes. Policy outcomes in terms of enabling AI for climate: ensure the availability of data, technology, infrastructure, and talent; deploy AI for climate, derive AI solutions for climate in public sector, and catalyze private sector action; guide AI for climate; promote environmentally and socially responsible use of AI. And the policy moves include many things: encourage data collection, encourage technology access, here in enabling AI, cultivate awareness and building expertise. Under deploying, you have define and deliver, encourage private sector adoption, and guiding AI for climate includes address environmental impacts of AI operations, the caveat, promote socially responsible use of AI for climate, so equity, justice, unintended consequences, and so on. There are many themes along which the policies, prescriptions or suggestions and what leaders can do are provided with examples. So I'm just going to take the main points of what the leaders could do to use AI for accelerating climate action. Encourage collection and sharing of climate-related data and tools across public and private organizations. Define standard processes and protocols for climate-relevant data gathering and sharing to ensure data is robust, trustworthy, safe, and respectful of privacy, because consistent quality control data is necessary to make global analysis or even regional analysis, because you are going to mix socio-economic data, physical data, and governance, ESG kind of data, census kind of data, and you have to make sure that everything is quality controlled and standard processes are followed. Create data catalogs across priority sectors for all climate relevant data categories such as weather, water, agriculture, energy use, and socio-economic factors. Establish AI and climate training and literacy programs for policymakers and the broader public sector workforce, so as capacity building. Build private-public partnerships to ensure affordable access and deploy locally or regionally critical AI technology infrastructure for cloud data centers, satellites, and so on. Empower the private sector to build and or expand AI technology infrastructure. Support R&D, research and development for AI technology infrastructure across the public sector, private sector, and academia. Support the creation and expansion of AI and climate-related upskilling programs for corporates. So basically there is a lot of anxiousness, anxiety about how AIs may take away jobs, and this needs upskilling of people who are in non-AI jobs and that need to find new jobs or fit into AI related jobs or AI driven processes in their jobs. Then upskilling is needed. So climate change training for AI experts and AI introduction for climate experts. So this is more narrowly focused on climate action and AI. Build AI and climate modules within education curricula. So early initiation for K through 12, cross skills for AI students or climate students, etc. My climate education is on climate education and not AI education or AI education for climate or climate education for using AI and so on. Integrate AI solutions and expertise into government strategic planning on climate priorities such as nationally determined contributions, national adaptation plans, sector-specific transition plans to carbon neutral economy or net zero economy and so on. Define priority sectors or use cases for AI to support climate action at local and regional levels, such as part of nationally determined contributions, national adaptation plans, and national AI strategies. Implement priority public sector AI solutions for climate, assuming AI is always going to reduce emissions and remove emissions and help with mitigation and adaptation and not, get in the way. Create public-private partnerships to drive AI adoption within and across key sectors and applications. Remove regulatory barriers to and provide regulatory support and clarity for AI adoption. Few more points before we close out. Accelerate infrastructure modernization and digitization to enable AI use. So AI can do a lot of things, but the systems have to be able to take the help of AI. Right? That's very critical. Support AI research and innovation in climate relevant domains by involving both academia and the private sector, and also users and stakeholders, governments, because they are going to be partners as well. Anything that you impose on people without involving them from the beginning can fail, right? Optimize incentives to drive AI adoption at scale for climate action priorities when existing mechanisms are insufficient, and examples are public funding, tax credits, etc. Promote transparency of AI's environmental impact and potential via pragmatic reporting guidelines and standards. So you can keep on saying how great AI is doing without saying what bad things it's doing. So you need to be transparent. Encourage AI technology providers to make robust sustainability and clean energy commitments and to adopt climate-friendly development best practices. Facilitate the adoption of sustainable practices for AI operations by supporting investments to reduce AI's environmental impact and removing barriers to clean technology adoption. For example, reforming planning for energy infrastructure, market rules, etc. And getting tired. Engage widely with all stakeholders to develop and communicate principles for socially responsible AI, addressing such factors as fairness, inclusiveness, safety, and data privacy. Create assessment frameworks to measure the alignment of AI applications with socially responsible principles. You cannot make a great AI that optimizes everything, including reducing and removing emissions, helping with mitigation and adaptation, but leave some groups out or have a negative impact on them. Okay, so again, short summary, but the report is very nice, available online. Please go and read it if you are interested in details, and there is very nice list of references as well. Okay.